Now the final presentation of this second part is Helena Westerlind. Helena is a PhD candidate at the KTH at the Royal Institute of Technology in Stockholm. So welcome, Helena.
Thank you. Thank you so much for the invitation. Great to be here. I will be the title of this talk is Programming Concrete, and I guess it hints or kind of speculates a future in which the materialization of concrete and digital technologies is increasingly intertwined. So the underlying hypothesis is that the concrete is a material that since the beginning has been shaped by mechanical operations. Casting in itself is one of the very first means of mechanical reproduction, as Walter Benjamin writes. And although the concrete industry has been extremely successful in terms of level of production, so I would argue that current manufacturing methods have contributed to both formally and materially reductive models for how concrete is used in the built environment, which ultimately has resulted in a very inefficient use of material resources. So although advances in material science and our understanding about the chemistry and the structure of concrete has improved, and it's possible to tailor the properties for specific purposes, as well as new structure analysis methods can provide the kind of digital blueprint of performance requirements at a more detailed level than before. Still, the process of casting then inherently depends on homogeneous mixes, and that creates monolithic structures. So material resolution ultimately exists at the scale of the mold and doesn't reflect the kind of heterogeneous structural stresses within the building component. So the need for kind of examining existing modes of fabrication then is made even more urgent by the enormous scale of concrete production worldwide that is only estimated to increase. The concrete supply chain depends on various geological processes, such as the sedimentation of limestone and the erosion of sand. But the enormous amount of raw materials required by the construction industry and the environmental impact of cement production is now in turn a significant force in altering the face of the planet. So in addition to the well-established association with kind of progress and modernity, we now have to kind of face the fact that concrete also plays a significant role in the exhaustion of the Earth's system. So what I'm interested in then is how digital technologies gives us tools for rethinking some of the kind of assumptions and conceptions that we have about concrete as a casting medium. Programming, in this sense, both relates to the composition of the material and how the kind of proportioning of the constituent ingredients can be tailored to perform in various ways, as well as new means of control and specificity in the way that the material is applied with the aid of computer-aided manufacturing. So in the process of 3D printing concrete, the conventional static formwork is replaced by the conventional static formwork, and the mechanical pour is replaced by a dynamic process in which the forming of concrete happens alongside programmed paths that can be instructed and combined in multiple ways. So this change represents not only a technical shift, but also a potential conceptual leap towards an understanding of concrete as active matter. So rather than being conceived as inert and passive, concrete of the future should be tunable, modifiable, customable, and programmable. The historian Peter Collins, that wrote about concrete, reflected that the fundamental antithesis of concrete design, namely that although the plasticity of concrete is by nature unlimited, this plasticity is in fact restricted by the practical limitations of the molds in which the concrete is poured. So a concrete building has essentially been built twice. The material's diverse morphology in architecture can be seen in relation to two contrasting tendencies towards, on the one hand, increasingly advanced formwork technologies to support the material's ability to take any shape, and on the other hand, the simplification of form in order to fulfill the material's potential to adhere to industrial workflows and economy of production. Even in the most efficient production line, the preparation of the mold remains the most time-consuming and labor-intensive part of the manufacturing process. Consequently, the building industry has developed various ways for making formwork construction more efficient. By simplifying shapes and employing orthogonal geometries, shuttering can be constructed out of large surface materials for quicker assembly. For this reason, concrete columns are frequently square in profile, although a circular profile is more ideal because of the flexural strength would be the same in all directions. Moreover, standardized building elements allow for reusable molds. In the post-war era, increased industrialization of the construction industry led to prefabricated manufacturing that produce building elements in mass quantities. On a conveyor belt principle, large orthogonal elements are cast vertically or horizontally on large platforms in metal molds held together by magnets. The more recent introduction of computer numerically controlled manufacturing processes and new formwork materials have introduced new possibilities for non-standard formwork. So materials such as EPS allows for accurate transfer of double curved surfaces and relief. In this building, which was the first large scale to employ this formwork technique, it's in Neue Zollhof building in Düsseldorf. So in here, all the individual panels were unique and they were milled and then kind of melted down and reused in a kind of very energy demanding process. And in this more recent building by Olof Eliasson, the fabricator kind of proudly boasts of the 4,500 cubic meters of formwork needed in order to make the formwork for this building, which kind of represents a 5-story building. So the kind of plasticity of concrete then, or its fluid expression, kind of comes at a great cost. Whether cast in situ or prefabricated, the process of casting inevitably adhered to a sequence of operations in which fresh concrete is displaced inside a pre-prepared mold. Concrete owes its fluidity to the presence of water, but unlike water, it has a certain resistance to deformation, which means that it doesn't necessarily self-level when poured into the mold. It slumps. Concrete success then, ultimately, as a casting material, it lies in overcoming this kind of resistance to deformation by vibration or by chemical additives so that it flues into every corner of the mold. Not unsurprisingly then, concrete itself is generally regarded as formless, abstract matter that merely act as a receptacle of form. Simply put, concrete is typically thought of either in terms of its liquid or its solid states. and kind of ignoring the kind of gradient of material behaviors in between. But this casting technique, for example, uses very viscous material in order to make hollow floor slabs with no concrete. And this project, which is by Smart Dynamic Casting by Gramatsu Kohler at ETH, kind of so it's a kind of slip forming casting that it starts at the bottom, and then as the kind of material stiffens, the mold would raise up, and it would also like use the kind of this resistance to then collapse, but it would like slightly turn it all the time. So it kind of uses these dynamic properties throughout the process. The process of 3D printing signifies a fundamental departure from conventional casting techniques, in that the materialization of concrete flow is no longer controlled by the opposing force of a predefined formwork, but by the self-supporting capacity of the material itself, coupled with the path of deposition. The process combines two main material operations, that of delivering material to the nozzle by kind of pumping the concrete, and that by placing it by deposition. So this means that the kind of rheological behavior, which is the fluid behavior of concrete, needs to be completely rethought, and its performance as the fresh materials needs to be kind of redefined. So this is then the implications of then having the kind of the fluid behavior of the concrete versus the imposition of a static formwork. So this is the timeline of properties. So the field of additive manufacturing in concrete, in concrete, was initially pursued by kind of few actors. So this is the diagram that shows four main fields, being academia, construction, design, and other. So actually, like other is more, there are more kind of DIY startups happening, and lately consortiums have kind of formed in between, for example, Foster and Partners, Skanska, and Loughborough University, to push this technology into a liable construction method. So early projects kind of explored hollow wall typologies, non-standard building components, surface textures, so the interest then in large-scale additive manufacturing is motivated by numerous and sometimes seemingly opposing agendas. For the construction industry, it kind of proposes the means of reducing costs involved in traditional labor-intensive construction. And it's motivated by commercial incentives for reducing human labor, cutting production time, and minimizing material waste. In the field of architecture and design, on the other hand, it is wishfully thought of or kind of projected as an extension to computational design and represents an opportunity to realize formal complexity in the physical realm. Frequently discussed advantages concerns its prospect of bridging the gap between design and fabrication, and the potential for reintroducing the bespoke and the non-standard in architectural production. And the process adheres to linear workflows in which a predetermined design is converted into slices and generated toolpaths through which the physical object is built up through the incremental forming of materials. Resolution, the kind of term resolution, is used as a measure to indicate how accurately the geometry of the materialized object corresponds to its digital counterpart. However, the kind of scaling up of this, which was initially a rapid prototyping process, is not straightforward. So the height, the time efficiency of resolution will always be kind of trade-off between the height of each layer and time. So it seems not very productive to think of it in terms of conventional 3D printing process. So the popular use of the term 3D printing, in which a materialized object is seen as a perfect copy or physical reproduction of a virtual model, clearly follows a tradition of making that upholds form as distinct from material, and that is deeply embedded in architectural discourse. Similarly, the common distinction between design and making upholds the representation of a building to be distinct from its actual materialization. In his attempt to raise the status of the architect above that of the craftsman, Alberti, in the 17th century, cemented architecture to be a discipline devoted exclusively to design and the formal outline of a building. The line is celebrated as a product of thought, according to which skilled workmen fashioned the material. Tim Ingold writes that when the word for drawing came to be the same as that for design, the line shifted from being the trace of a gesture to a geometric projection of a conceptual image. Similarly, Katie Lloyd Thomas writes that the orthogonal drawing is the principal method for developing and representing design, and describes only form and relegates material to the empty spaces between the lines. So it seems then like 3D printing is reproducing some of the principles that have conditioned or has shaped concrete as a casting material. However, so what we I would suggest that we need is kind of new models of representation in order to enter the grain of the material of concrete. So, and this has kind of historical precedence. Sorry, I should have said this. So this is the this gray field is just showing the outline of like all of the kind of recipes that have been developed for 3D printing concrete kind of falls within this bubble. So what I would say is the challenge is to develop material mixes at the extremes of these the possible properties of concrete. So we have a library to choose from. So the practice of kind of varying concrete properties has historical precedents. For example, in the case of the Pantheon, they were choosing different kinds of stones for aggregate that they collected from the surroundings. So this is, I mean, in a way, it's a kind of representation of the geopolitical context of Rome. So they would use travertine, for example, at the lowers, which has a very high density, and then at the top, a very light volcanic stone that they imported from Naples. So a contemporary example of this is a research that is going on at the Institute for Lightweight Structures in Stuttgart. And here they have, I mean, in this case it's a beam. They have, through structural analysis, then made a gradient map in which they have an inverted kind of relationship between density and porosity. Yeah, thank you.
Hello, hello. Yes. So we invite the speakers to the table to enter up a conversation. And I really open up the floor for questions. If any one of you have anything to ask to any of the speakers. Adrian?
Well, this is a question for David Jolly. And can you tell us whether the columns that you've cast at Open City, this range of varying columns, do they all have the same strength? Do they have the same compressive strength?
I submitted the design of the columns to an engineer, and he decided the way the structure inside it should be, as well as the foundations. These first columns are supposed not to have anything up, but something light. They may have maybe some wooden structure, but they are not going to support a building. So they must support themselves and support an earthquake. So they have a calculated foundation, as well as the steel inside. We did later on, I didn't show it here, a structure done with the same technique, and that one also has an engineer analysis in order to support the building and in order to support the earthquake. So they have inside a whole structure.
Nevertheless, is there not a question as to whether some columns are stronger than others? They maybe all meet a minimum requirement, but some have have more.
Have more, yes, because the engineer did an analysis based on a central cylinder. So if they have more, they will be stronger if they have more concrete on the outside of this basic cylinder. It was calculated that way.
I ask because one of the questions, it seems, about fabric formwork is the difficulty of calculating the strength.
I see.
As I understand it.
Yes. I think, as we were talking before, we start here the seminar, that Remo Pedreschi in Scotland, he did some laboratory essays concerning the strength of the columns, some columns done model columns, and he determined that the ones that are, how do you say, wider than the cylinder, they were 1/3 stronger than normal cylinders. So there are some measurements done in that way. Of course, if we have a big curve like that, it's object of another analysis in order to stand still and behave in a whole structure. But we do work with engineers. We are not here in Chile. We cannot do something without the help and the, how do you say, la seguridad of an engineering analysis. Do I answer your question? Good.
Any other questions?
I guess this question goes to Erik. My question is, what are, in your opinion, the possibilities of wood, like the material, to being as developed as the concrete has been done up to today, in the sense of building like I don't know, 5 stories building, like in a seismic country like Chile, for example, or in Sweden? I mean, is it happening? Is it developing as quick as concrete, or?
Is this on? Yeah?
Yes.
Yes, it's happening in Sweden. We are building high buildings in wood right now, but we don't have the earthquake conditions. So I don't know, but likely the prospect of building tall buildings in Chile will be possible in wood. But I don't think it's a material. What I was trying to present was not purely a material question. Whether concrete or wood, it's how that concrete or wood is put together into a system and for what purpose. And that is where I find we are less well prepared today than we were in the 60s in Sweden to provide that solution.
Thank you. Something that emerged from both your talk, Eric and Helena, is perhaps implicitly, and perhaps you have been thinking about this with regards to the future, is what will happen with labor. If say, the promise, also related to your talk earlier, if the promise of prefabricated concrete panels had taken the industry, the whole industry, or eventually 3D printing, of course, everything will be designed earlier. The role of architects will change somehow. And it's one of those things that really boost economies. So if you inject money in the building industry, you have more work. And I guess that's an important question for the future.
I mean, I don't, in terms of kind of robotics and fabrication in general, I mean, I think it's just a kind of, I think of reorganizing labor rather than things disappearing. That's what I think.
Would you cut jobs after, say, 3D printing takes over the industry?
Mm. I mean, jobs in terms of the people putting together the formwork, yeah, but they will be doing other things.
So we had, during the Million Program era, when we were building 100,000 units per year, we had 350,000 people in the building sector, in workers in Sweden. Today we have 320,000 building 40,000 units. So there's, if you talk efficiency and labor, there's something to be done there. And unfortunately, what's happening with the post-capital deregulated building industry is that what we see is actually the architects are being cut out and the engineers are put in order to produce more environmentally friendly building, but then we find that it's too expensive or it doesn't make the environment that the residents want. And so there's a challenge there where I would say we need more architects rather than less. So let's re-educate some of the builders into architects.
Can I reframe that? Just an aspect of the question that perhaps when you think it globally, it will make a difference depending on which countries will make a transition quicker and where designs will be produced initially, say. Which countries will be more easily transit from one sort of range of skillment to another? Which countries are more prepared for that? So I imagine what will happen in Latin America. I guess the transition will be different if those designs or those ways of buildings are imported from other countries that have, say, more skilled population or workforce related to, say, design or information technologies. To me, it's an open question. I wouldn't like to.
You? You're asking him, yeah?
No, I think it's a wider discussion, and that one is obviously very interesting also in terms of where is society going in terms of the mechanization, and you're using just the building industry as one example because it's already happening in other industries. I think the reason that the building industry, at least in Sweden, is the most conservative, least innovative, is twofold. One is that material is extremely slow moving. So electronics is faster, and it's faster to put a device in our hands and to make us get used to that, rather than restructuring financial, economic, industrial process that building involves. And the other side is that there is an idea in the building industry that we know how to do things, and I think this is probably that conservative viewpoint is probably the most difficult to surpass, and therefore all of the digitalization and mechanization that's going on today in terms of robots is really not using technology to break that conservative building industry. It's just doing the same thing in a different way, which with 320,000 people building 40,000 units a year is more inefficient than what we were doing before we had digital technologies with 350,000 people building 100,000 units a year. So we're a pretty dumb monkey right now.
Any other questions? Between you guys?
Well, I liked the synergies between your talks. You know, pushing mold, but more in a craft perspective, and then the talking about the potential of changing the inside of the concrete in your talk, Helena, and that those two should definitely be combined, because obviously, if you're calculating the cylinder, you should be calculating the whole mass, and you should be adjusting the concrete load-bearing capacity to the shape.
Of course.
And that could be a given next generation. So there was a great intersection there for a new project.
Of course, but we don't have here this kind of concrete you show, the difference in density.
Mm-hmm.
I've never seen it here.
But it's just about varying the mix. It's about the proportioning of the mix.
In each layer.
Yeah, and sorry, I should have mentioned, in the beam they sprayed it to get this kind of resolution, the gradient.
They sprayed
They sprayed it. Yeah.
the concrete.
Mm.
I haven't seen that that technique. I see. No, because with the flexible formworks, you may also have this, how do you say, ahorro? ¿Cómo se dice ahorro? Saving material, because it's very, for instance, I didn't show it here, but we're able to do beams that follow the momentum curve, so you don't have useless concrete as in prismatic beams.
Yeah.
So it's a very good thing. But I agree absolutely with what you said about a traditional way of being in construction, because I think maybe it's one of the most traditional, how do you say, works on earth. Is really difficult to change something. Maybe in a way could be because of the cost, because if you do something wrong, you must take it out, and it cost maybe a whole wall some millions of pesos, and it's not just a drawing that is very cheap. So I think that it comes from the big amount of material you use for building, that each error or each things that is not well done is a lot of money. I think it comes from that. Oh, could be one reason, because I have had the experience of working with flexible formworks, and at the beginning we used a sewing machine, and once you bring a sewing machine into a building place, chantier, all workers run out. They won't stay. So we took the sewing machine out. We can't use it.
So what did you do instead?
We use almost all how do you say, simple pieces of fabric, not sewn, just flat ones, and we give the shape with the plywood. So no sewing.
In terms of innovation in the buildings industry, I mean, at least in Europe, like I don't know what's here, it's because it's also like a lot of kind of small actors, so there's not a kind of centralized body as well to kind of push innovation and investment, and there is a high risk. I mean, if you push something new, and so in order to kind of also in order to kind of change standards, you have to group together, which kind of defeats the purpose as well, because you kind of develop something because you want to, be ahead. So I think that also contributes.
I have a question for you. Did you see the way the guys on the ETH did these columns, changing the formwork?
Yeah, it's a robot that kind of holds the mold.
And how the molds change the shape? Because there was one that started...
just by rotating the mold.
Yeah. It's the same one that rotates?
Yeah.
I see. Interesting.
I have a question maybe for the three of you. Maybe you could comment. Given that you both were showing columns and your system is based on columns in order to make it flexible, which relates to maybe the name of this building, the Innovation Center, where we are trapped in innovation because as soon as we innovate and we get a result and we're ready to build, someone else is innovating again. So we are always trapped by the continuous flow of innovations where nothing remains, and it seems that nothing can really solidify it into an actual practice. And that maybe is one of the reasons why the builders keep going with some old practice, because all the rest is like innovation in MIT or ETH or somewhere else. So I'm not sure if you could comment on this issue of where we could stabilize some common ground for innovation in order to really grasp a possible futures for concrete, instead of keep continuing, like finding new solutions with not a problem, or with an unclear problem. Because in a sense, what you're saying, Eric, is that's a real problem. It's the same problem we had 50 years ago. It's like you need to put forward X amount of new houses, right? So you don't really have the time to implement all the innovations going on in faculties of architecture. So I'm not sure if maybe you could comment about this issue of the opposition between innovating and putting stuff into practice in a more solid basis.
Yeah, I agree completely with what you're saying. And usually when a house is tendered or ordered, then you want the house to work from day one. You don't want it to be an experiment, and especially if it's housing that you live in. So the housing sector tends to be extra conservative because there's no room for failure, and this keeps innovation down. But looking back at the period, on the post-war period, from the 40s up until the 70s, the innovation that was really pushing was regulation. So it became a way of how and who influences regulation. How do we make sure that all parts involved get their say and then find the best possible increase of quality or financing or education or knowledge, and therefore they managed in a very short period of time to rewrite lots of regulation, whereas now we turn to industry and think that all innovation shall happen there, that because that's the way of technology, is that technology happens in a startup and then it catches on and then suddenly everybody is using Microsoft. But in the building industry, it doesn't happen that way, I don't think. I think it has to be much more of a cultural shift. And so that's one part of the answer. And the other part of the answer, then if it's a cultural shift, we can look at the hardcore environmentalists that say that we already have all the built space we need in Sweden, for example. I don't know how it is here in Chile, but in Sweden we have all this built space we need if we are to survive the planetary goals, the environmental goals. So to contribute to the maximum 2-degree goal, we need to redistribute ourselves within that space. And this is even more radical. How do we restructure culture and see that as innovation, rather than thinking that it's a product in the home or the product in a building that's going to be the solution for one of the challenges. So it's about changing how we live, how we act, and using the architecture as a means for that.
I mean, I think in terms of the concrete industry, it's also a matter of necessity and the fact that concrete is way too cheap for kind of the innovation that I was kind of hinting at for happen, where those kind of considerations are at the forefront. So yeah, I don't know, policy.
Are you saying it's too cheap
It's too cheap.
to make it just one way, and therefore nobody will change the way they work?
So it's too cheap because it doesn't reflect the cost that it has on the environment.
It's like flying.
Yeah.
Bueno, a mí me pasa que como arquitecto, ante la pregunta que tú haces, me ocurren algunas, como decir, definiciones previas. Por ejemplo, si uno mira la ciudad, partamos desde Grecia, como mostré en algunos dibujos, ¿no es cierto? La arquitectura en Grecia estaba en el Acrópolis, no estaba en todos lados. La placa, creo que se llama hoy día la parte que está abajo, ¿no es cierto? No era arquitectura, era lo que cada particular podía hacer. Ahora, si miramos las ciudades contemporáneas en cualquier parte del mundo, ¿no es cierto? Evidentemente que hay obras de arquitectura que uno las reconoce como tales. Y el resto uno la podría llamar edificación. Y el ser humano, alguien se podría preguntar si vive, digamos, la arquitectura tiende a ser una plenitud, donde la vida humana se dé plenamente. Y se podría decir, o podría postularse, ¿no es cierto?, de que si uno está en una edificación, sobrevive, pero no vive. Ahora, la línea, como decir, en Grecia la arquitectura estaba en el Acrópolis y en ninguna otra parte. Y hoy día, ¿no es cierto?, la arquitectura moderna tiende a postular de que esta dimensión arquitectónica de la Acrópolis está en todo lugar que un arquitecto ha concebido. ¿Por qué? Porque concibe lo que está haciendo como una obra, que es una plenitud para la vida. Ahora, el punto es, ¿cómo decir? Que en todas las exposiciones que hemos visto, los problemas pueden ser otros, porque por ejemplo en los edificios que tú mostraste, ¿no es cierto?, se trata de una solución habitacional para una gran cantidad de gente. Ese es el problema. No es que los que pensaron esos edificios estuvieran pensando de partida en la plenitud así, sino que estaban pensando en que tenían que darle casa a una gran cantidad de gente que venía al campo, con una densidad grande dentro de la ciudad. Entonces, el punto está en cuál es el problema en el cual estamos, ¿cierto? Ahora, lo que tú presentas de la innovación, yo me imagino que si sigo, como decirte, dentro de este discurso que tiene como horizonte la obra, las innovaciones serán bienvenidas en la medida que entren en alguna obra. Ahora, evidentemente que este es un tema, como quien dice, discutible, porque no es que sea, como quien dice, algo que pudiéramos decir es una suma algebraica, no, es una postura. Algunos piensan que la arquitectura es un arte, otros piensan que es una técnica. Entonces, bueno, son distintas posturas, ¿te fijas? Ahora, ¿cómo decirte? Me acuerdo que Alberto Cruz decía que había algunas posturas arquitectónicas en la cual había una utopía en la cual se pensaba que el ser humano podía vivir en un panal de abejas. O sea, que no requería de una casa singular para sí mismo, sino que podía vivir en el hexágono de un panal, como si fuera parte de la naturaleza. Bueno, esa es una postura. Hay otra que dice, no, cada uno singular. Ahora, ¿cómo se da la singularidad en el habitar? Bueno, a lo mejor en una ¿cómo lo llamé? En una edificación, la singularidad se da en un arte muy popular hoy día que se llama la decoración, por ejemplo. Por ahí se salva. Pero yo creo que es un problema ante el cual estamos, por lo menos los arquitectos.